Okay, last lesson of the chapter 8, lesson 7. Probably a couple days of review after this, and we're going to test. So I think that's a Friday test start. So it is what it is. But anyway, let's get circled up. We have numbers 1 through 8, and then we're going to start on page 639. So you can see that right there. So we're going to go 1 to 8. And excuse me, flip it over here. And then I'm going to jump to numbers 14 through 24. So there's not a ton of work here, but we certainly need to show our work. Okay. And we need to do a good job. This test probably won't be very, very easy, unfortunately. So let's get after it. Today we're going to be solving inequalities, and we're going to relate that right to equations. I tied that back in a few lessons ago, but now we're definitely going to have to show our work. We're definitely going to have to graph things and so on, okay? So make sure that you're very meticulous with your work and follow right along, and I'll take you right through it, okay? All right, so to solve an inequality, what we do is we continue to balance beam, and we do the inverse operation, right? What's left over here is h. H is greater than or equal to 19. You'll catch me putting an equal to sign here, so I'll have to erase sometimes. So now I need to graph this solution, okay? And I know I'm just going to kind of do it over here, right? Okay, so let's go 17, 18, 19, 20, 21. I just kind of skipped that area. I'm going to go to the number 19 and I'm going to circle it and fill in the dot. I'm going to close the dot because there's an equal to sign. H is greater than or equal to, and I'm going to draw my line that way. So I've graphed this solution. I've showed my work. You have to show your work. You know that. Number 2, we're going to balance beam. And I'm going to tee this up because 5 times some number is greater than 30. So the inverse of multiplication is division. I'm going to divide both sides by 5. Y is going to come down. 30 divided by 5 is 6. So y is going to be greater than 6. And again, I'm just going to start this right here. 3, 4, 5, 6, 7. I started too low, didn't I? I'm going to come to the number 6. I'm going to leave it open. And I'm going to draw it that way because y is greater than 6. It doesn't include it. Okay. Jonah's parents give her $10 a week for lunch money. She cannot decide whether she wants to buy or pack her lunch. If a hot lunch at the school costs $2, write and solve an inequality to find the maximum number of lunches, number of times per week Jonah can buy lunch. Okay. So she gets, all right, if a hot lunch is $2, all right, and we know she has $10 per week. $2 per lunch. How many lunches at $2 and still be less than or equal to 10, right? This number has to be, it could be 10. It's got to be less than or equal to, right? So I'm going to divide both sides by 2. X is, well, I did it right there. It went. I went too fast. Less than or equal to 5, right? So Jonah, the maximum amount of lunches she can buy is 5 lunches, right? Okay. No graphing there. Tino's Pizza charges $9 for a cheese pizza. Eileen has $45 to buy pizza for the Spanish Club. Write and solve an inequality. Okay. For the maximum number of pizzas, that they can't go over 45. So here's $9 a pizza, 9p. We'll call it because for the pizza. And here's 45. Could it be 45? Yes, she could spend all the money, but she can't spend more than that. So that's why Eileen is going to be 9p is less than or equal to 45. Okay. Balance beam, tee it up, divide by 9. P is less than or equal to 5. Okay, so she can buy 5 cheese pizzas at the most, no more. Okay, so you're getting the idea of this. We're going to do a few more of these, and I hope it's working out. You just got to take your time. All right. All right. Let's continue on here, and let's do numbers 2. Let's do numbers 2, 4, 5. Okay, maybe even 6. We'll see. See how what time provides here. Number 2. What number minus 1 is less than 4? Plus 1, plus 1. W is less than 5. 4 plus 1 is 5. So 5, 4, 3, 2, and so on. I circle W. I leave it empty because there's no equal to sign, and I go that way. Okay. Now, our graphs are going to be different, and that's fine. As long as you're graphing it correctly, I'm just doing this over here a little bit to keep it out of the way here, okay? Balance beam. D divided by 3 is less than or equal to 2. We're going to multiply by 3 and multiply by 3. This side cancels. We know that from our equations. D is less than or equal to 6. 7, 6, 5, 4, 3, 2. I go to the number 6. I'm going to circle it. I'm going to fill in the circle because I have an equal to sign. D is less than, so I got to draw it less than or equal to 6. Okay? All right. We're rolling right along here. Number 5, a company charges 10 cents for each letter engraved. Bobby plans to spend no more than $5 on engraving in a jewelry box. Write and solve an inequality. Okay. Well, if we're going to spend 10 cents for each letter, how many letters, and I'm going to use X, I don't want to use L because I get my L's and 1's confused. How many letters can they get for $5? Can they spend $5? Yes. Can they spend more than 5? No, you can't spend more than what you have, right? What number times this? So the inverse of multiplication is division. This cancels, and I'm going to bring my X over here. And I did it again. I told you I'd do that. X is less than or equal to what? This divided by 10 cents is 50. So it's 50 letters, right? X is less than or equal to 50 letters. That's the maximum amount of letters that they can get. And you could use your calculator for that. I'm just saving a little bit of time here. Okay, moving on. And the final one I'm going to take a look at is this nice word problem about Sonic Rock. Here we go. So I have some extra money to get a shirt at the concert. Each shirt's $14.50. Suppose David has $65 to spend on his ticket and some shirts. Okay, he already spent $32.75 on his ticket and fee. Write an inequality that could be used to find the maximum number of shirts he can buy. Okay. Well, here's the thing. If he spent $32.25, all right, on his ticket and his fee, what does he have the maximum number of shirts he can bid? All right. So what I would tell you is we need to take $65 and subtract $32.25 from it. And when we do, all right, we're going to end up with, is that right? That's a 4, I'm sorry. $32.75. That's what he has left to spend. Okay. So if each shirt is $14.50, right? How many shirts, which we'll call X, can he get for $32.75? Can he spend $32.75? Yes. Can he spend more than that? No. So it has to be less than, correct? So there's a couple steps here. And again, I had to take the total amount, subtract what I spent. This is what I have left to spend. balance beam. Tee it up. I'm going to divide both sides by 1450. This cancels. X is less than or equal to what? Well, let's see. I'm going to grab my handy dandy calculator and go to work here, right? Because this is why we have it. 3275 divided by 1450 is 2.258. So, all right, X is less than what? 2. And I'm not going to write all this decimal out because I can't have 0.25862 of a shirt. So X has got to be less than or equal to 2. He'll have a little money left over. The most he could buy is 2 shirts. So good question there. Okay, guys, keep cranking, keep pushing. All right, excellent lesson. Have a good day.